Diamond setting has evolved through thousands of years of jewelry making. Throughout the times, innovations in casting and metallurgy have allowed a variety of occupational specialties to emerge within the jewelry industry. Today, a typical trade shop employs a number of jewelry technicians. Their talents are combined to serve the needs of retail jewelers. Special orders are first designed by a proficient jeweler who can interpret a customer's wants and needs. The artwork must be presented in an improved image that is structurally and economically feasible to manufacture. A considerable amount of experience is required in all phases of jewelry manufacturing to envision the completed piece. Each step of the assembly is conceived while anticipating problems and other variables at this stage. After a design has been approved, a wax prototype is carved. This is a full-scale model from which a casting will be made. The wax is carefully sculptured to reveal the design exactly as it has been intended. A high degree of skill and foresight is necessary to develop such a pattern. Very little tolerance is acceptable. A slight deviation in design of geometrics could entirely alter what had originally been perceived by the designer. From here, the wax is placed in an investment plaster flask to be vaporized in a burnout furnace. Then, molten metal is cast into the cavity to form the jewelry piece. When the rough casting has cooled, it is then filed and emeриed to be made smooth. Finer details are tediously cut and sawed into the casting in reference to the original design. Multiple shapes and sizes of files, saws, and drills are used to do this. Critical decisions are made concerning specific features and strength requirements. Also, unforeseen problems that could have been caused by a number of variables are detected and solved at this time. Assembling the mounting is the next phase. Settings are added to accommodate a range of stone sizes. A jewelry technician performing this task must be skillful at soldering techniques. Furthermore, the technician must have a knowledge of related chemicals in order to effectively and safely perform the task. Other soldering techniques include common jewelry service, such as sizing, retipping, and usual repairs. Polishing is another phase of jewelry service. This is a finishing process that involves a matrix of buffing wheels, brushes, and polishing compounds. Combinations of precious metals used to manufacture jewelry and their varying alloy contents are numerous. Each requires a specific series of integrated techniques to obtain an abrasion-free design. Acquired skills to reveal the true luster of gold, platinum, or silver can determine the success or failure of a jewelry service. The last phase of a jewelry service is the final inspection. During this stage, jewelry is cleaned by professional methods, which often involves an ultrasonic machine and steam. The most efficient and effective methods are applied to ensure that quality is presented at the highest standards. Then, the jewelry is inspected to the finest detail. This is a personal critique performed to exceed the customer's expectations. One of the most rewarding and intricate professions to develop from this diversification is that of the diamond setter. Diamond setting can provide a challenging occupation, as well as rewarding and satisfying to an ambitious, creative, and mechanically inclined person. Many successful craftsmen of the trade, even those having several years' experience, will admit that they learn something new every day. However, the prospective diamond setter must have a desire to strive for perfection with intricate detail and have creative ability. Also, and probably the most important prerequisite, is the need to have an aptitude of mechanical inclination. While considering a career in diamond setting, one should take a serious personal inventory and have no doubt that these qualities are well established. Diamond setting, in comparison to other skilled crafts, is also one that requires a period of apprenticeship. An apprentice who has a desire to learn and continually improve skills could have a very enjoyable experience. If the apprentice does not foresee the results of training nor accept delayed gratification, then the training period will be inflicted with excessive toil and hardship. Even to an experienced diamond setter, ambition is a necessary reinforcer that promotes growth in skills. Otherwise, productivity stagnates, and, depending upon the individual, boredom and monotony can eventually occur, resulting in dissatisfaction and ultimately a change of career. However, it is unlikely that a diamond setter who is highly skilled in the craft could project artistic values to any such degree without first having the desire and ambition to progress from the very beginning stages of training. Another necessary quality of a diamond setter is to be creative. That is, in applicable terms, the ability to envision the result of an arrangement of precious stones and to perform the necessary task that will enhance the adornment of the jewelry piece as a whole, as well as the individual components. Because of new designs in jewelry fashion, changes in production processes, and increasing advances in technology of tools, equipment, and raw materials, the work of the diamond setter is enriched with creative possibilities. Creativeness as a value of the diamond setter ensures that interest will be maintained. In the absence of creativity, the perfection of a true artisan could doubtfully be accomplished. Mechanical aptitude is also a prerequisite of a successful diamond setter. One must have the ability to work with a variety of tools in a constructive manner. This involves a coordination between the functions of the mind and body. A diamond setter must have the ability to perceive a goal and to control physical exertions toward the accomplishment of that goal. Having the previously mentioned values of persistence, perception for detail, and control over one's own motor skills, the career-oriented person could enter an occupation of diamond setting. This occupational specialty offers rewards of professionalism and integrity. But, like any other skill, the dues of an apprenticeship must be paid. Given the proper guidance and a fair chance to prove oneself, the qualified individual should be able to advance in the trade to a career level that is both rewarding and satisfying. The diamond is not a rare stone, nor is it the most valuable. However, it undoubtedly exceeds all others in interest. Its chemical makeup is nothing more than crystallized carbon, but it is separated from other stones because of its unique physical characteristics. The atomic structure is that of a cubic system. The result of this structure is the favorable optical qualities of a diamond after it has been cut. These qualities are the refractive index, a capability of the faceted stone to reflect light; color dispersion, the amount of sparkle in a diamond; and the hardness. Diamond is the hardest substance known, but its hardness is granular and subject to cleavage. In effect, diamonds can be chipped. The facets of a diamond that pertains to a diamond setter are the table, crown, girdle, pavilion, and culet. These will be referred to throughout this video. Typical of other skilled mechanical trades, the profession of diamond setting also requires an assortment of specialized tools. The care of them is essential to their durability, not only because of the expense involved, but also because the craftsman becomes adapted to his or her own tools. A certain amount of any artisan's performance is derived from becoming accustomed to handling familiar work objects. The workbench is the arena of the diamond setter. It is the workplace where most work-related activity is conducted. Although designed to accommodate tools of the trade, it also must be adaptable to the craftsman. The constructional dimension should be such that the work can be accomplished comfortably over a period of several hours. Tools should be placed in a systematic order of priority. This is where the most used are the most easily accessible and in a familiar location. There are two reasons for good organization. First, for example, if tools are scattered about, a pair of chain nose pliers of the miniature variety may be substituted in a task requiring pliers designed for a larger stronghold that cannot readily be found. Here, the misuse of a tool for a purpose that it is not suitable for may result in a broken pair of pliers. Another reason to organize tools is efficiency. Diamond setting requires the use of many small hand tools. One cannot conduct himself or herself in a professional manner if he or she is continuously searching for tools. Such a trade as diamond setting requires several tool changes each hour of the day. Eye loops offer close viewing for detail inspection of jewelry and diamonds. Some monocular loops are in the form of one or two lens mounted into a small tubular structure. A single lens that clips the side of eyeglasses is more accessible. For diamond setting purposes, a 10-power eye loop is recommended. Binocular loops, on the other hand, are acceptable for continuous viewing. These loops provide viewing for both eyes simultaneously, thereby offering dimensional viewing. Two types available are those attached to a headband and those that clip onto eyeglass frames. Ring clamps are used to hold rings and certain other jewelry for work. A common ring clamp is made from two pieces of hardwood clamped together with a swivel action between them. With a ring held at one end, a wood wedge is forced into the opposite end, causing the ring to be clamped tight. Another ring fixture is called a benchmate. This is a trademark name. It has unique features that allow the ring to be worked at multiple angles. It is sturdy, durable, and permits the diamond setter more freedom of movement. One of the most common diamond setting tools is beeswax. The primary purpose of this pliable material is to handle diamonds. When used to handle diamonds, it should be shaped into a tapered form. Other uses are as a lubricant for saw blades and burrs, and to lay out diamonds. A millimeter degree gauge has a number of uses for diamond setting. One primary purpose is to accurately select the correct size burr as compared to a diamond being set. A spring gauge with indexes graduating in 1/10 millimeter increments is appropriate for diamond setting. Side cutters or flush cutters are used to trim excessive lengths from prongs. This is a necessary practice because prongs are normally too high in new settings. Effective cutters used by diamond setters for this purpose are of the slim line or miniature type. Dividers have multiple uses for diamond setting. A basic purpose is to mark equal depths onto prongs so that bearings will be cut level. Other uses involve laying out diamonds on a jewelry piece in order to determine where they will be set. The steel points inscribe exact spacing between diamonds into the softer precious metal. A flex shaft machine is a durable machine tool used to hold and operate burrs, drills, and other small shaft tools. Burrs are tightened into the handpiece by a chuck and key. Operation of the machine is controlled by a foot rheostat that regulates the speed at intervals up to the maximum RPM. Burrs are small cutting tools of various shapes and sizes used to remove metal, shape metal, and to cut bearings into mountings to set diamonds. A shaft extends from each burr, allowing them to be inserted into the flex shaft machine handpiece. Diamond setters ultimately develop their own styles of bearing cutting, which involves a particular selection of burrs. High-speed setting burrs are highly recommended for most bearing cutting procedures. The expense is offset by the durability of the burr provided by the tool steel quality. Alternate sizes of these burrs allow a perfect seat for the diamond. The top of the burr provides a straight bore, while the bottom cuts a bearing at an angle conforming to the pavilion of the diamond. Pliers are used to secure diamonds. A slim line chain nose type is especially suited for diamond setting. They are tapered to grasp, bend, and manipulate prongs and other small sections of metal. A prong pusher is a metal shaft inserted into a graver's handle to bend prongs onto the crown facets of the diamond. The tip of the shaft should be either grooved or V-shaped to contain the tip of the prong without slipping. Several types of files are familiar to the jewelry crafts, most of which are not necessary for diamond setting. A prominent diamond setter will eventually narrow the use to a selected few. A suggested beginning inventory would include a number 3 flat-hand file, a number 4 Barrett needle file, and a number 6 3/4 needle file. Another popular burr is a cup burr. Cup burrs have a concave tip that contains cutting edges inside. It also extends from a 3/32 inch shaft. Although they are not extremely durable, they pay for themselves in time saved to round prong tips to create a beaded effect. A variety of sizes is recommended. Pumice wheels serve to remove scratches and indentations from jewelry metal. Knife-edge pumice wheels will ideally pay for themselves. The time saved in cleaning up the diamond setting and eliminating excessive polishing is notably worthwhile. The importance of good precision tools is not to be undermined. Each tool is designed to perform a particular task, and it is the craftsman's responsibility to see that all tools are cared for and used properly. It is a well-known fact that the tool does the work. The craftsman's skill is limited to controlling and guiding the tools to achieve the desired outcome. There are 7 basic phases to any diamond setting procedure. These are 1. Inspection, which includes the mounting, diamond, and their compatibility for assembly. 2. Layout. This is an envision and preparation phase. 3. Cut the bearing. 4. Seat the diamond. 5. Secure the diamond. 6. Finishing. And 7. Final inspection. An inspection of the mounting and diamond should be the initial phase of any diamond setting procedure. This is done to ensure that the assembly can result in a lasting product. Considerations include the characteristics of each and their compatibility for assembly. A thorough approach is suggested in order to discover any material defects that could prohibit the diamond setter's craftsmanship. Particular details that will cause deviations from the normal procedure are noted at this time. In general, the purpose of the inspection is twofold. First, to familiarize the craftsman with the characteristics of the mounting and diamond. And second, to find a justification to either question the assembly or continue with the procedure, taking the unfavorable aspects into account. When inspecting the diamond, the aid of a 7 to 10 power eye loop is necessary for close viewing. To hold the diamond steady, use either beeswax tapered to a point or adequate sized tweezers as a fixture. Particular attention is given to multiple top views by rotating the diamond. Imperfections are more readily seen from those angles. Natural imperfections to check for are flaws, carbon, and on a lesser degree, the clarity and color. These characteristics should be known in order to prevent problems that could develop because of them during the setting procedure. Natural flaws are positioned in non-conspicuous areas, such as under prongs. Examine the diamond from a side view to reveal the cut. A thick girdle facet or extended pavilion will indicate that the technique to cut the bearing later will be altered. Conversely, an extremely thin girdle facet requires special precautionary measures because it will chip easily. The precise method to set a diamond is determined in part by the characteristics of that particular diamond. There are valid reasons to check the diamond for chips, flaws, and imperfect cuts. First of all, if a chipped diamond is not reported to an immediate supervisor or customer prior to setting it, then the craftsman might inevitably be blamed. Secondly, flaws and imperfect cuts will have a direct effect on the setting procedure. Inevitable problems can usually be foreseen by conducting a visual and sometimes mechanical inspection of the mounting. A diamond setter should be able to readily recognize inadequacies and imperfections in a mounting from problems incurred in the past. The best precaution is to anticipate the effects that each move will have throughout the remainder of the procedure. There are several things to consider when inspecting the mounting. Three predominant factors are the design, quality of metal, and strength. Design is foremost because it is usually obvious at first sight how the diamond will be set. For example, the absence of prongs would imply that a prong setting procedure is not applicable. Examine the metal for defects such as pits and deep abrasions that could affect the procedure. Estimating the strength of the mounting is important because a certain amount of abuse to the metal is often necessary in order to set a diamond. Additional inspections of the mounting include the craftsmanship by which it was manufactured. Check to see if the setting is soldered straight. It is to the diamond setter's advantage to become aware early in the procedure of any improvisions that must be made because of the mounting. Also, consider the chemical makeup of the mounting. Features such as the color of gold and gold content usually give some hint as to the vigor necessary to perform the procedure. For instance, yellow gold is commonly softer than white gold, and a higher carat rating usually signifies a more malleable and pliable mounting. If necessary, use an eye loop to search for a carat stamp. The condition of the mounting in diamonds has little significance if they cannot be assembled. Comparing the dimensions of the materials is a feasibility part of the inspection phase. The objective is to decide if a procedure can be initiated that is in compliance with the design. Modifications and alternate plans are considered for tactical purposes, but not necessarily executed at this time. Those decisions are reserved for the layout phase when the precise strategy and related details are more thoroughly developed. A good technique to determine the compatibility of the mounting and diamond is to physically compare them together. Try to envision what the completed assembly would look like. One test is to place the diamond on top of the mounting. The decision can then be made as to whether or not the prongs can be spread in or spread out to accommodate it. Also, place the diamond to the side of the mounting. This is another brief test to determine if the diamond can be set securely and at a sufficient height in the setting. Prongs can be adjusted in or out to accept a variety of diamond sizes. This is the beginning of the preparation stage. To make a prong adjustment, use slim-line chain nose pliers. These pliers must be small enough to maintain visibility while working one prong at a time. Hold the pliers as shown, perpendicular, with the thumb braced against the ring fixture to keep from slipping. Grasp the entire length of each prong to keep them straight. At first, adjust each one the same distance in or out, unless any are not symmetric to the others. Be careful not to distort the metal. Afterwards, compare the diamond to the mounting again. The diamond should barely extend onto each prong tip. This is not likely to be the final position of the prongs, but it is a good starting point to prepare for the procedure. Furthermore, the diamond has to set low enough to allow an ample amount of metal to secure it. At the same time, the diamond's cullet should not extend too low. There should be some clearance between the diamond cullet and the base of the setting. Raise the diamond up and down against the setting to envision an attractive height. Other adjustments to the prongs are usually necessary to straighten them and to be sure that they are equally spaced. Again, chain nose pliers are used to do this. Grasp the prongs squarely between the jaws of the pliers and bend them from the base of the setting. Up to this point, the mounting and diamond have been inspected, and with some minor prong adjustments, they have been found to be compatible. Now, the layout phase can begin. The layout is the development of a strategy to assemble the mounting and diamond. For the most part, the influential characteristics of each are detected beforehand during the inspection phase. The task now is to determine how the diamond can be securely and attractively set into that particular mounting. One of the first steps in this phase is to cut the prongs down to a suitable height. Use dividers to engrave tick marks at the tip of each prong where they will be cut. If the diamond is set too high, the prongs will have the unstable effect of long table legs. Under that condition, the diamond will eventually become loose. Keep in mind what the bearing depth will be from the tips of the prongs. It will be about 1 1/2 times the distance from the height of the diamond's girdle facet to its table facet. Next, use small diagonal cutters to clip each prong at the tick marks. Hold the cutters level to the prongs. After positioning the jaws of the cutters, place a fingertip over it as shown. This will keep the prong fragments from flying after it is separated. Remember that the prongs will later be filed level to the lowest prong tip. Be careful not to cut any of them too low. Perfection is particular to a diamond setting procedure because corrections are usually more tedious and time-consuming than if it were done right the first time. Poor judgments made in an early phase often have a lasting effect. Likewise, mistakes that cannot be fully compensated result in a devastating effect on the finished product. During the layout, a diamond setter should foresee and prevent problems that could develop throughout the remainder of the procedure. Consequently, a picture of the finished work will be envisioned. In general, the techniques that will be applied to each succeeding phase is thought out at this time. In order for the diamond to eventually be set straight and level, the tips of the prongs should be filed level to the ring shank. Use a number 3 flat hand file to do this. Hold the file level on the prongs as shown. Develop a feel for its position before applying pressure. Use slight pressure from the extended index finger on the forward strokes. After each movement, observe the effects. Occasionally rotate the mounting to check the progress from all angles. Be careful not to file the prongs at a slant. The tips of the prongs should be on a parallel plane to the base of the setting. Take time to file the prongs as specified and don't overdo it. The effects of this technique will be most noticeable when the bearings are cut. At that time, all bearings are cut to the same depth from the tips of the prongs. If the plane across the prong tips is not level, then ultimately the diamond will not be set level. After every step, stop to inspect the work. If machining was done, then brush the loose metal to get a clear view. Briefly place the diamond on the mounting to be sure that everything is going as planned. To ensure that the bearings are cut level into each prong and the diamond can be seated level, use dividers to mark the prongs. There are a couple of things to consider here. For one, the girdle of the diamond is seated at the vertex of the bearing, and the vertex of the bearing is cut to a depth that is about 1 1/2 times the distance between the girdle and the height of the table facet. In this case of a 1/2 carat diamond, that depth is about 1 millimeter more or less. To cut the bearings, select a high-speed setting burr that will fit inside the setting without connecting to all of the prongs. If the burr is too small, it will get out of control when power is applied to the flex shaft machine. That will damage the metal. The burr shown here is an ideal size to cut one prong at a time. Hold the burr shaft firmly and insert it into the flex shaft handpiece. While applying a low revolution, use the other thumb to press on the chuck teeth. This should cause the burr to be centered. Then, use the chuck key to tighten the burr. Dip the burr into cooling oil or other tool lubricant and begin cutting the bearings at the divider tick marks. Hold the handpiece with the burr perpendicular to the setting. The index finger extends from just above the opening of the chuck along the opposite side of the handpiece. Place the thumb against the near side of the handpiece at a 90-degree angle. The tips of the other fingers extend beyond the burr to brace the top of the ring fixture and control the burr from shifting to either side. At first, this may be an awkward position to hold the handpiece until the muscles develop. However, it is important to adhere to it, allowing only slight variations in order to maintain control of the burr while it's rotating. Operate the foot rheostat at slow to medium speeds. A little pressure on the burr will be necessary to help it cut into the metal. Bearings are cut a little at a time while intermittently inspecting them. One good technique is to first cut each prong just enough to start the bearings. The objective of this first series is to begin the bearings at an equal depth on all prongs. Also, each bearing should be centered on the prongs, being careful not to cut to either side. The metal is cut gradually in stages to be sure that the bearings are being formed equally and to avoid removing too much metal. After the initial cuts are made, stop to examine them. If any bearings are not level or not being developed properly, then they can still be corrected. There should still be plenty of metal to work with. The purpose of a bearing is to provide a stable and secure resting place, or seat, for the diamond. It should be cut to a depth and width into the prongs that an adequate amount of metal will remain to secure the diamond later. Removing too much metal in either direction will affect the security and cosmetic features of the setting. The depth of a bearing is a distance that the vertex of that bearing is below the tops of the prongs. Specifically, a vertex is the turning point of a bearing where the angle abruptly changes slope. There is a medium level between too deep and too shallow that varies depending upon the size of the diamond. This, as mentioned earlier, is about 1 1/2 times the distance from the girdle facet of the diamond to the height of its table facet. The lateral distance to cut a bearing is usually about 1/3 to 1/2 way into the prongs. That will provide a stress relief point for the metal to bend freely at the vertex and still allow an ample amount of metal to tighten the diamond. Don't try to complete the bearings too fast. Take plenty of time during this phase to cut the bearings equal and continually inspect them in case adjustments have to be made. When approaching the end of the bearing cutting phase, be more critical during the inspection. Brush metal shavings from the setting and use an eye loop to examine the bearing on each prong. There will usually be some adjustments that can be made. Keep in mind that the bearings must be level. Besides the probability that the diamond will not be set straight, a wedge will occur when the prong tips are bent over to secure the diamond. This happens when one bearing is higher or lower than the others and is the most common cause of chipping a diamond. Also, although the lateral distance cut into each prong is limited, it still has to be far enough to allow the metal to bend without excessive force. During the time bearings are being cut, an extension of metal commonly builds up along one side of the prongs. This should be removed for cosmetic purposes prior to setting the diamond. Attempting to remove the metal after the diamond is set could be hazardous to the diamond. The protruding metal can be shaved off easily at this time by a sharp, flat graver. Hold the graver at a low angle alongside each prong and push in a downward direction. It isn't necessary nor advisable to cut into the prongs. This can be avoided by placing the graver nearly flat to the prongs. Hold the graver as shown, with the thumb braced against the ring fixture. Slide the graver along the thumb for steadiness and to control the cutting action. Seating the diamond is usually a trial and error process. It often involves placing the diamond in and out of the setting and making minor adjustments to the prongs. Use chain nose pliers to bend the prongs as needed. To do this, grasp the entire prong firmly between the jaws of the pliers and bend it from the base of the setting. To keep from slipping, brace the thumb against the ring fixture. Be careful, because applying too much pressure could indent the metal. When the diamond can be seated, it should have to be slightly pressed into position. Use a fingernail to do this. Press the diamond down at each prong until it is level on all bearings. Check the seating from all angles, being sure that the diamond's girdle facet is completely flush to the metal. If there is a space between a prong and the diamond, then take it out and make adjustments now. After the diamond is secured, it will not be as easy to straighten. Use small chain nose pliers to secure the diamond. Miniature pliers are ideal because they limit excessive leverage and offer an unobstructed view for observation. Position the inner side of one plier jaw flat against one prong to brace the setting. Then squeeze them gently to bend the opposite prong tip slightly over the diamond. Reverse the plier position to bend the other prong tip. Repeat this technique to each prong while watching the diamond for movement. If it shifts out of level, then stop to make a correction. At first, the prong tips are bent just enough to make sure that the diamond will be snugly seated. Do not try to tighten the diamond at this time. After all of the prong tips are partially bent, stop to check the progress. The diamond should be snug, straight, and level, but not necessarily secure. Continue bending prong tips onto the diamond by repeating the technique for a second time. Take time to perform the tightening process. Securing diamonds should always be done in a gradual manner. Use a little more pressure, but still don't try to close the metal completely to the diamond yet. The diamond could shift if a prong is prematurely bent too far. Observe the metal as it moves and use peripheral vision to watch the diamond. The key to this technique is control and positioning of the pliers. With the correct placement of the plier jaws, the angular spread should induce them to be positioned correctly. Shade the bench light with one hand to inspect the setting. Look for gaps of light between the prong tips and the diamond. By this stage, the metal should only have to be closed just a little farther to secure the diamond. Once the prong tip stops bending as detected by feel and vision, stop. It will not move any further without damaging the setting or chipping the diamond. Check the diamond for tightness. To do this, lightly grasp the girdle facet with tweezers and attempt to turn it. The lightest effort should be applied, or else the diamond will become loose or chipped. To begin the finishing phase, first file the tops of the prong tips flat to a level that is slightly above the table facet of the diamond. This will result in an ample amount of metal for average size beads. Use either a number 3 flat hand file or a Barrett needle file. If the prong tips are heavy, they can all be filed together. Otherwise, file one at a time. It's important for cosmetic purposes that all the prong tips are equally sized and the same height. File only on the forward strokes, and after each stroke, briefly pause to observe the effects. At this stage, there will be a sharp point on each prong tip extending over the diamond. These should be pushed down to ensure the finished setting will not have catchy prongs. Use a groove prong pusher to pinch the metal flush to the diamond's crown facet. Push towards the diamond to avoid loosening a prong. Try rolling the edge of the prong pusher in a burnishing motion over the prong tip. Be careful not to contact the diamond. That could cause it to become chipped. This is a tedious technique, but is necessary for practical and cosmetic purposes. While working around the diamond, keep a watchful eye for any other improvements that can be made at this time. Use a number 6 3-square or Barrett needle file to remove sharp edges from the prong tips. File on each side of the tips in a curving direction towards the diamond. This will help the cup burr that will be used in the next step to cut with a minimal effort, thereby allowing it to perform more effectively. Filing is done at this stage to pre-shape the prong tips as desired, but will not leave a rounded finish on the metal that is quite as smooth as what can be done with a cup burr. Do not remove a lot of metal, just enough from the sharp edges to make the tips somewhat rounded. Actually, the prong tips can be shaped to any common form by filing. There is no standard shape of prong tips, although the bead or rounded effect is most common in today's fashions. A fine-cutting 3-square or Barrett needle file is adequate to do this. Either of these files will normally slide across the diamond's facets while shaping the metal without endangering it. Pressure should be applied only to the prong tips, although the edge of the file will be in contact with the diamond. One note of caution is to avoid filing against the girdle facet, since a diamond is most likely to chip there. After extended use, the edges of a 3-corner needle file will eventually become worn from contact with diamonds. Do not be concerned about this because the cutting sides of the file will still be useful. The file is really better for this purpose after some wear because the smooth edges lessen any chance of damaging a diamond. Furthermore, this particular file should be kept separate from others and used exclusively for the purpose of filing prong tips. Use a cup burr to cap the prong tips. Select one that will cover the tips without touching the diamond. Conversely, if the cup burr is too small, it will distort the metal. Insert the correct size cup burr into the handpiece. When the burr is friction locked, tighten it with a chuck key. Place the cup burr lightly on a prong tip before applying power. Gradually increase from slow to less than medium speeds. Some pressure might be required to keep the burr in position. Shift the burr from side to side in the opposite direction of spin. This will help it to cover the entire tip. Hold the burr where it will not cut into the back of the prongs. Be extra careful not to rotate the burr against the diamond. That could cause the diamond to become chipped or loose. Any burr rotating against a diamond will more frequently dull the burr. Using a cup burr has an obvious advantage of machine power to round the prong tips quickly. More importantly, the tips can all be shaped to the same size and formed into perfect beads. Use cup burrs cautiously and occasionally stop to brush metal shavings away and inspect the progress. Use an eye loop to examine the prong tips. Look for flakes of metal that extend onto the diamond. A sharp graver or similar tool can be used to remove the excess metal. Position the graver at an appropriate angle on each side of the beads to do this. Shave towards the diamond lightly, being careful not to cut into the prong tips. Cutting in a direction away from the diamond could cause a prong to loosen if too much force is exerted. Also, avoid contacting the girdle of the diamond. A slip or misuse of the graver could damage a girdle facet. Flakes of metal extending from the beads are unsightly and interfere with an appearance of fully rounded beads. They develop because of a revolving cup burr. The outer edge of a cup burr that does not cut burnishes the metal and forces it in an outward direction. The result is a flattened protrusion of metal clinging to the bases of prong tips that reach onto the diamond's crown facets. Extreme cases are caused by using a cup burr that is too small. However, some distortion of this type is common because gold is malleable. When the prong tips have been cleaned, there will be an improved difference in the beaded effect. Smoothing metal is the final segment of the finishing phase. After finishing techniques involving filing, using a cup burr, and trimming have been completed, the sides of the prongs will be rough. They should then be made smooth in order to minimize polishing. This can be done with various shapes and sizes of rubber wheels. Finishing materials such as these can also become abrasives if not used carefully. A touch-and-go technique to check the effects of each action is a must. There will be a lot of fine debris extruded from the materials combined with gold dust that will obstruct a clear view of the mounting. These should be brushed away occasionally during the smoothing process to inspect the metal. Lastly, minor imperfections in the design discovered at this time can usually be corrected by expanding on the same smoothing techniques. First, use a large rubber wheel that has a straight edge to smooth wider areas of metal, such as the back of the prongs. This metal is usually left indented by pliers during the beginning of the procedure. Use the rubber wheel in a brushing manner. Apply long strokes covering the prong's length. Stopping midway or concentrating on one area too long will cause the metal to become gouged rather than plain. A medium power or revolutions per minute will not allow the rubber wheel to cut smoothly. On the other hand, the use of high revolutions will increase chances of the rubber wheel to get out of control. There is one final point to consider when using a large rubber wheel. That is, the edge of the wheel should be flat. Otherwise, it will not contact the entire width of a prong. To get a flat edge on a large rubber wheel, brush it against a coarse hand file while rotating the wheel at medium speeds. Don't do this to a good file because the rubber wheel will destroy it. Keep a separate file for this purpose. The same file and technique can be applied to a knife-edge pumice wheel. The next step is to smooth the metal alongside the prong tips. First, remove the large rubber wheel from the handpiece and insert a knife-edge pumice wheel. Make sure that the shaft is centered in the chuck before tightening, otherwise it will not operate smoothly against the metal. The pumice wheel should be sharp so that it will contact only in the crevice formed between the metal and diamond. Keep the wheel moving in a brushing manner to avoid gouging the metal. Above all, don't let it rotate against the beaded tops of the prong tips. Maneuver the wheel in a direction down from the crown facet over the girdle facet. The sharpness of a girdle facet will cut a pumice wheel if the wheel is rotated against it. Watch closely as the pumice is worked on each side of the prong tips. The objective is to smooth the metal, not to remove too much or reshape it. After using the pumice wheel, brush the setting to remove loose dust. An unobstructed view is necessary for a final inspection. The final phase is to inspect and review the setting. Use an eye loop to look for imperfections that can be corrected. Critique the work to see if any improvements can be made. Check the diamond for tightness. See that it is set level and straight. The prong should be symmetric with the tips, equal in size, and flush to the diamond's crown facets. In review, this diamond has been set by following 7 basic phases that were listed in the beginning. Again, these are 1. Inspection, including the mounting, diamond, and their compatibility for assembly. 2. Layout, an envision and preparation phase. 3. Cut the bearing. 4. Seat the diamond. 5. Secure the diamond. 6. Finishing. And 7. Final inspection. Any diamond setting procedure, however complex, will involve this same format. Finally, in order to perfect this or any other diamond setting procedure, the prospective apprentice must have a combination of personal prerequisites. These are ambition, creativity, and mechanical inclination. Those characteristics, along with knowledge presented here and acquired skills in various techniques, a prominent candidate could become a successful diamond setter.